Hello children, welcome to channel Sube. Children, today I am going to discuss question number 47 from the MCQ part of 2021 Physics new syllabus paper. A conducting sphere of radius 2r is given a charge of positive 3q. Another uncharged conducting sphere of radius r is touched to the first sphere and then separated by a distance simple r, as shown in the figure. What is the electrical potential energy of the system now? In brackets, assume that the charge distributions of spheres are uniform and the system is in free space. So there are 5 answers. So let us try this. So children, the story is this bigger sphere has a charge positive 3q as like this, but the smaller sphere doesn't have any charge, so it is neutral. So what happens when they are touched together? Let us take a copy. Then this smaller sphere is moved towards the bigger one and touched like this. So what happens? The charges from this bigger one flows to the this neutral sphere because it has no charge. So imagine that there are 2 tanks, water tanks like this, 2 water tanks like this, and they are connected by a tube, horizontal tube like this. So there is a valve. Suppose this first tank has water full like this, second tank has no water, it is empty. So what happens if you open this valve? Then water flows from the first one to the second one and fill in the second one also. So this level drops, and finally while this level is dropping, what happens? The level of this tank increases like this, and finally at a certain height, the heights are equal, they come to the same level like this. So after that, no water is flowing across this valve to the second tank. So that is the final steady state, equilibrium state. So the heights are equal, the energies, the potential energies are equal since heights are equal. So potential is what now we are going to equate of these 2 spheres. So that is the key of this problem to solve it. So after that, we don't have 3q here because suppose an amount of x charges came to this sphere, and the remaining amount of charges in this on this sphere, bigger sphere, is 3q minus x. This one is the final remaining charge because x came to this one. So previously this bigger one had 3q. So 3q minus x is the new value after becoming to the steady state. So at that time the voltage means the potential of this one is suppose V, and this one also gains voltage, say V. So those 2 V's should be equal to each other, like that tank, the h heights of these 2 tanks were equal. So let us therefore write V equals V. V equals V. What is the equation basically for V? 1 over 4 pi epsilon naught Q divided by the radius of the sphere. This is the potential of a sphere. Potential of a sphere. So we can use that equation. So for this bigger one, we can write 1 over 4 pi epsilon naught. Now it has 3q minus x. That is the charge. Now it has 3q minus x. So what is the radius? So this one. So we have written now the q value. Now we are going to write the radius value. Radius is 2 times r. So it is not squared as if we do in the force equation. Force equals 1 over 4 pi epsilon naught q divided by r squared or d squared. But here in this equation you can't see any square, so it is linear, not a square. So equals to the smaller one, smaller sphere, this one. That is also, we write that same equation, 1 over 4 pi epsilon naught. The q is now x of this one. The radius is simple r, 1 r. So that's all we have to do. Now we have to simplify whatever possible. So this one 1 over 4 pi epsilon naught is cancelled. So this one also cancelled. So remaining 3q minus x divided by here 2 equals only x at right side. So cross multiplication, then 3q minus x equals 2 times x. So when you take this x to the right side positive, then 3x equals 3q, then x equals q. That means the final charge on this small sphere is q. Previously this bigger one had 3q, so 1q came to this one, and now remaining 2q. Positive 2q is the charge that is remaining on this bigger sphere. So altogether 3q is there. So now we know the charges. What they want is not the charges, potential energy. What is the equation for potential energy? This one is the potential, not the potential energy. This is the potential, not the potential energy. If there are two charges, like this and like this, point charges, if the distance is d between them, between the centers of these charges, if the charges are q1 and q2, the energy, potential energy is given by 1 over 4 pi epsilon naught q1 q2 divided by the distance. So this is the equation for that. So now we have two charges, but the difference is these are spheres, not point charges. But there is a principle that we can suppose for any external calculation. So we are now calculating the potential at the external surface, not inside something. So for such a case, we can assume that this total charge is gathered at the center as a point charge, So therefore we can do that, the same results we get even though it is a sphere or a point charge for only external calculations. So therefore we can assume this as a point charge. Now it has positive 2q. This point charge has q positive. The distance is What is the distance? From here to here 2r, because the radius, and from here to here r, and this one also r. So r, 2r, there is another 2r here. So all together 4r. This one is r, and this one is r. Total this one is 2r, and here there is another 2r. Then altogether 4r. So the distance between this one is 4 times r. So therefore we can now substitute that. So the distance is 4r. We are taking these spheres as point charges. 4r. So let us write the equation now. Potential energy equals 1 over 4 pi epsilon naught, then 2q times q, q1, q2, divided by the radius. The radius means the distance. Distance means 4r. So we get 2q squared. 4 times 4 is 16, 5 epsilon naught r. So then we can simplify. 2 cancel, then here 8, then q squared divided by 8 5 epsilon naught r. So this is the final answer. Q 5 epsilon naught r. 8 q divided by q squared divided by 8 5 epsilon naught r. Q squared divided by 8 5 epsilon naught r. This one is the answer, second one. So let us check. The question number is 47. 47. For 47 the answer is 2. Correct, answer is 2. So we received the second one as the answer. So children, I think you understand. You can understand this. Only 2 equations we used. The equation for potential and equation for potential energy. You should know these equations by heart. If you don't know these equations, you can't solve actually these types of problems. So these are not big issue. So let us now try some target questions. So children, before we go to the target question, I have to explain there is another method to get the charges after touching. It is like this. As previously, suppose this one has x charge and this one has 3q minus x after touching them. So like this. So we can use the capacitance. Capacitance of a sphere is 4 pi epsilon naught r. Capacitance. So suppose the capacitance of this one is C1, capacitance of this one is C2. So let us write the equation for the bigger one. C1 then equals, then R is 2 times R. Let us write separately. This one is the common equation. So C1 equals 4 pi epsilon naught 2 times R. For the smaller one, C2 equals 4 pi epsilon naught simple r. So divide each, first one divide by second one, then this term cancel, r cancel, then we get C1 equals 2 times C2. So this is the relationship between capacitance. So now what we want is the relation between the charges. So capacitance C equals, the basic equation is Q equals CV. So here we isolate C, then we get Q divided by V. So if we write this equation for the first one, the bigger one, C1 equals Q1. Q1 means 3Q. So let us write Q1 just divided by V. V is not 1 and 2 because the voltage, the potential after touching is same. So V, this here. Then we write the equation for the smaller one. C2 equals Q2 divided by the same V. So we can now substitute these two, this first one, first, second, third, let us suppose, then 1 and 2, 2 and 3 to the first one, substitute. Then C1 means Q1 divided by V equals 2 times C2 means Q2 divided by V. So V cancel here, then Q1 equals 2 times Q2. So Q1 means now our Q1 is 3Q minus X, 3Q minus X. Then equals 2 times Q2 is, in our case it is X, so here X. So we take this X to the right side, then 3X equals 3Q, then we get X equals Q. That means we can finally write Q here instead of 3Q. What is 3Q minus Q? Previously this one had 3Q, now Q amount of charges came to this one, so remaining is 2Q. So here this one has 2Q. So like that we can find out the charges of each spheres, and after that we have to follow the these steps as previously, So after finding Q, we have to now equate voltages, the potentials. V equals V, so potential is 1 over 4 pi epsilon naught Q divided by R. So this equation we have to apply now to the both spheres as we previously did, therefore I am not going to do it again. So I just draw an arrow to this place, find the potential energy, then thereafter find the potential energy. Like this. So this same thing you have to do. After that, potential energy is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by distance, not squared, distance only, linear. So like this we have to substitute 4R for the bigger one, and follow these steps as previously we did, so we get the same answer. So that is the second method that you can follow, starting from the capacitance of a sphere. So children, now let us go to the target question. So children, I changed the data of this problem, and here is your target question number 1. So now what you have to do is read the question carefully, and without watching my solution, honestly try to solve this problem after pausing the video. A conducting sphere of radius 2r is given a charge of positive 6q. Another uncharged conducting sphere of radius r is touched to the first sphere and then separated by a distance r as shown in the figure. What is the electrical potential energy of the system? Now in brackets assume that the charge distributions of spheres are uniform and the system is in free space. Now I am going to start the calculation. So let us take a copy. So after touching, suppose that this one gets amount of x, so this one has 6q minus x now. After touching, the final charges are like this at equilibrium state. So the voltage potential is now V and V equal. So we write V equals V to find out the charges. So you don't have right now 1 over 4 pi epsilon naught, all those are cancelled. Now you can use the short method, just the charge of the bigger one and divide by the radius 2 times r. R also will cancel, therefore we write only 2 equals, then again 1 over 4 pi epsilon naught, you don't have to write, that cancel both, then only the charge is x, so divide by 1 r. R here you don't have to write because with this r it gets cancelled. So 1 also you don't have to write. Like this we get the equation. Then cross multiplication you have to do, then 6x minus 6q here, 6q. Because previously it had 6q. So x came to this one, so now remaining 6q minus x. So 6q minus x equals 2 times x. So take this x to the right side, then 3x equals 6q. So x equals 2q. So now we know the relationship. Then we can write it here. So now we have here x equals 2q, this x, instead of this x now we write 2q positive. So previously this one had 6q, now came 2q to this smaller one. Now what is remaining here? 4q. 6q minus 2q, then 4q positive. So then what we do, consider it as a point charges. These are as point charges, so this distance is 4 times r. After that what they do, they don't leave it like this, they separate. After that they separate this one after touching like this to the r distance. So now the distance is 2r, 2r, 4r. Then the potential energy equation, we write 1 over 4 pi epsilon naught Q1 Q2. Q1 Q2 means Q1 is 4 times Q, Q2 means 2 times Q, divided by the distance. The distance is 4r. Then simplify. 4 times, let us cancel this 4 to this one, then 2 q squared divided by 2 q squared divided by 4 pi epsilon naught r. Again we can cancel this 4 like this, q squared divided by 2 pi epsilon naught r, because there are 2 times for this 4. So this is the answer, divided by 2 pi epsilon naught r, 2 pi epsilon naught r, this one. Third one is the answer for this question. What happened to your answer? Is it correct? So if it is correct, you are genius. If it is wrong, you have to follow again this method from the beginning itself and start doing the first target question again, because you were not able to keep the method in your head, that is due to lack of experience. So again you have to do this first one, the original one, and few times you do it to receive this answer, then it will go to your head, go into your head, and then you will be able to do this on your own. So now let us go to the target question 2. So children, here is our target question number 2. As previously, you have to try this on your own, honestly, without watching my solution. Pause the video and try to do it. Let us follow the same pattern. Suppose amount of x charges came to this smaller one, so the remaining charge of this bigger sphere is 9q minus x after touching. Now the voltages must be equal. So we don't write that 1 over 4 pi epsilon naught term, because there are 2 at the left side and right side, they get cancelled each other. So we just write the charge divided by the radius 2r, but r also get cancelled, therefore here charge, only charge, divided by 1 r get cancelled, 1 also we no need to write. So 9q minus x equals 2x, 9q equals 3x, x equals 3q. Now what we do? Now we separate. Before that we have to write the charges, new charges. We don't want the voltage now. So the charge here is x equals 3q, we have obtained that, 3q. So remaining charge of this place is 9q, previously it had 9q, so 3q came to this one, So now 6q is remaining here on this bigger sphere. So now what they have done is separating this one to a distance surface to surface r. So the center to center, the distance is 4r. 4r, because here 2r, r, 4r. Now potential energy equation 1 over 4 pi epsilon naught q1 q2 means 6q times 3q divided by the distance 4r, not t squared, and simplify. 6 times 3 is 18 q squared, 4 times 4 is 16 5 epsilon naught r. So divide by 2, this becomes 9 squared q squared, then divide by 2, 16, then 8. This one is the final answer. Furthermore, we can't simplify because we have received a 9 here. 9 divided by 8, 9 divided by 8 q squared. So this one is the answer for this question. So children, here is our target question number 3. So you have to try this on your own without watching my answer. Honestly, do it. Pause the video, read the question, and follow the previous path. So let us touch this in. Then assume the amount of charge flow into this one is x. So the remaining charge of this one is 4q minus x. Then voltages must be equal. Therefore V equals V. Instead of V, we write without 1 over 4 pi epsilon naught term, 4q here, minus x divided by 3, the radius is 3 times, equals x divided by 1 r cancel. So now we know x is equal to q, this one is equal to 4q it had previously, then 4q minus q came to this smaller one, then 3q is remaining here. Then thereafter what they have done, moving this one away so that the surface to surface distance is r equals to r. distance r. Now the center to center distance is how much? 3r, rr, 5r. So energy equation, now we have to delete this 4q. There is only 3q now. Here there is 1q. Energy potential equals 1 over 4 pi epsilon naught. Charges 3q times q divided by the distance 5r. 3q squared 20 5 epsilon naught r. This is the answer. Furthermore, we can't simplify. 3 divided by 20, this one. Fourth one is the answer for this question. Question number 3. So let us do now this target question number 4. So we have to follow the same path. Suppose x came here, the remaining charge is 5q minus x here. After touching, the voltages are equal. So three r equals x divided by 2r. Here 1 over 4 pi epsilon naught. Because the original equation is so this cancel, and also r cancel. Cross multiplication. So now let us delete this x and write x equals 2q and 5q minus 2q is 3q. Now separate. Distance r. then center to center 3r, r, 2r. Here 2r, r, 3r, 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 6r. Distance between center to center is 6r. Okay. Here 2r, r, 3r, then here 3r, altogether 6r. Then equation for energy. Q positive 3q times you have to write this sign of the charge, otherwise once they didn't give marks in the essay paper if the sign is not appeared in the equation. Therefore, when you write these charges, remember to write the sign also. Positive 3q times positive 3q like this, then divide by 6r, then 3q squared furthermore, can you can simplify, divide by 3, then q squared 8 times 3 times 8 is 24, isn't it? 3 times 8, 8 times 3, 16, 24, yes. Q squared divided by 8, 5, this here I haven't written this 2q, I have write here what 2q, 3q I had written 2q, then 3 times 2, 6 here, then 4 yeah. Divide by 6, 4 times 2, 24, q squared by 4, this one. So children, here is your next target question, question number 5. Try to do this. So I have changed totally the question, so this may be a real target question. Next time, if you are lucky, you might get. So children, what happens? Due to the faint wind, this small sphere moves towards this large one and touches. then what happens? Then this one has 3q charge positive, then the same thing happens. That means suppose x amount of charge come to this one and the remaining charge is 3q minus x. So we have to find the value of x. So what we do, the charges are flowing only until the voltages get equal. So that means we can equate voltages of these two spheres. So 1 over 4 pi epsilon naught. We don't have to write these things as previously. We can directly write 3q minus x divided by the radius 2r equals x divided by r. 1 over 4 pi epsilon naught. Then these people cancel, this r also cancel. 3q minus x equals 2 times x. 3q equals 3x. X equals as previously q. So now we can delete this x and write the result we received. The charge is here q. Now the charge is 3q minus q is 2q. Positive, positive. So now we have to delete this one. So same charges, what happens? Repel each other. Repel each other like this by a force. This one also has the same force, get the same force. So according to the Coulomb's law, we can write F, the initial F, equals 1 over 4 pi epsilon naught. Charges are positive 2q times positive q divided by the distance between two centers is what? 3r. 3r, 2r plus r. But 3r, the total thing squared here. Remember, the force equation has a square value. This one is the force equation, not the voltage. In this voltage equation we don't write a square, that is linear. So simplify 2q squared, then 4 pi epsilon naught, 3 times 3 is 9 r squared. So this one cancel, 2 here, then q squared divided by 9 times 2 is 18, 5 epsilon naught r squared. The force, initial force, this one is the answer, 18 r squared, this one. The second one is the answer. So children, what happened to your answer? I don't know what happened. If it is correct, you are genius, because this question is totally different, but there is a little relationship with the previous ones we have already discussed. But here's something you have to think on your own, not just follow the path. You have to use your brains. So if it is correct, we can say there is a brain inside your head. So let's go to the target question 5. If it is wrong, what you have to do, again follow the previous exercises. That's what everybody does. So children, here is your target question number 6. Number 6. You can do this, try this after pausing the video. So let us write the equation for V. 6q minus x divided by 2 equals x divided by r. R means r cancel. 2x plus x, 3x. X equals 2q. So now we can delete this and write 2q. Then subtract 2q from 6q, because previously this one had 6q. So now 2q came to this smaller one, so remaining 4q. Positive positive repel each other, therefore there will be a force, repelling force like this. So we have to find out the force acting on the small sphere. So Coulomb's law, Q1 Q2 is positive 4q times positive 2q divided by distance 2r r 3r. So brackets 3r squared, remember. Then 4 times 2 8 q squared divided by 4 5 epsilon naught 9 r squared 36. So we can simplify. 2 times 2 8 2q squared divided by 9 5 epsilon naught r squared 2 divided by 9 here. Third one is the answer for this one. So children, now the final target question number 7. Do this. So children, what happens as soon as this small one touches with this large one, since it has negative charge and this one has a positive charge, they mix and cancel each other, then the remaining charge of the system is this one, positive plus negative 3, then the charge of this one will be positive 3, yeah. Positive. The negative 3 mix with the positive 3 from this 6q, and they destroy each other, and the remaining value of then 3q, positive 3q. So then thereafter this positive q, positive 3q is divided between these two, so that the voltages are equal, until the voltages are equal. So therefore, as previously, now we can suppose x charge come to this one, 3q minus x charge remain here. So v equals v, then 3q minus x divided by 2, the radius is 2, equals x divided by radius is 1. Then 3q equals 3q, 3x, then x equals q. Then that means we can now draw like this. So let us place an arrow here, from here to here, this way. Delete this one, and x equals q, here q, delete this one, 3q minus x, 3q minus q is 2q, positive 2q is remaining here, this one delete. Then what they ask is the force, force. So force equals 1 over 4 pi epsilon naught, positive 2q times positive q. You must write the signs of charges in the equation, remember, otherwise you don't get marks. The distance between centers is 3r, so square it 9r squared. So 2 cancel, 2 here, q squared, 9 times 2 is 18, 5 epsilon naught r squared, 18 r squared, 18 r squared, this one. So children, now I am going to wind up the video. Here you see all what I have done, a lot of work, you see, up to 7 target questions. So this one is the 7, this one is the 6, 5, 4, 3, like this. Big job, huh? So you must be happy. I think you are happy. If you are happy, you have to make me happy too. How you can make me happy? by subscribing my channel if you haven't still subscribed. If you have already subscribed, don't press that button again, then it will be cancelled. So you can, what else do, share my link among your friends and press the bell icon and press the thumb up button. And thank you very much for watching my videos, children, and thank you very much for subscribing my channel, children. Then see you tomorrow at 6 o'clock. Goodbye, children.